But the rest of you. After walking 25 kilometers due south, a hiker then walks 20 kilometers due east. What's the total distance walked by the hiker? Is this the quiz that we're marking, quiz number 2, or did I give you a different one? So this is the one? Okay. Oh, and those of you that were away last class via video, we marked quiz number 1. So you have a 0 on those quiz number 1s. You better find that answer key online. You better mark quiz number 1 and email me your score, because those NHIs are going to stay there. Yes, Mr. Dueck's a little bit grumpy. Total distance. Let's bring this back. Distance. Oh, that's a scalar, McKenna. That's just going to be 25 plus 20. I can do that in my head. 45 kilometers, 1 mark. Total displacement. Displacement, John, that's a vector. So I'm going to add these together, and I'm going to add these together tip to tail. And since I see directions, I'm going to write a little compass rose here, north, east, south, west. And then I'm going to add 25 due south plus 20 due east. How do I add 2 vectors together, Zach? Draw them tip to tail. John, what that means is I have to draw the 25, and then at the tip of the 25, I have to put the tail of the 20. I still have a few of you that are drawing these incorrectly. If you draw them incorrectly, you may fluke into the right magnitude because the Pythagoras will still work, but I'm telling you the degrees and the what of what aren't going to work. The resultant is always, Matt, my friend, from the tail of the first to the tip of the second. There's the resultant. There is the displacement. Okay. You get a half mark if you drew that picture, or if you drew 20 plus 25. I'll give you a half mark for that too. Now I do the Pythagoras. So the displacement is going to be 25 squared plus 20 squared. 25 squared plus 20 squared. Square root. Does this work out evenly? No. 32 units, kilometers, and then I need an at. I need a direction. I will not tell you necessarily to give me the direction. You need to know which ones are vectors and which ones are scalars. On the rest of your tests, if it's a vector, I have no problem, Jordan, putting in brackets magnitude and direction. But on the vector test specifically, where I'm actually testing, do you know the difference between a vector and a scalar? Then I'm going to say, on that test only, it is fair game for me to say, hey, clue in if it's a vector that I want magnitude and direction. Okay. There's my theta right there. I don't know what the angle is going to be, but that's going to be east of south. It's going to be tangent, which is 20 over 25. 20 over 25. Do you get 38.6? I'll go 39 degrees. 38.7, but I'll go 39 degrees. Or you could also have 90 minus 39, 51 degrees south of east. So here's how I generally mark these. I give you a half mark for the diagram. I give you a half mark for the magnitude, a half mark for the angle, and a half mark for the what of what. Is that okay? Number 2. 2 students are pushing heavy bench. They want the resultant force. I've scrolled down, so I'm going to put a north, east, south, west compass rose again. East, 255. North, add those together. McKenna, my angel, how do I add these together? Draw them tip to tail, which means what I'm still seeing is some people go, oh, that plus that. No. That's tip to tip. That's going to give you a completely different vector. It's going to be, now I'm going to have to think about this a little bit because I know I'm going north. I'm going to have to move this one down here for my triangle to actually like fit. It's going to be, here, let's try that again with a straighter line. Not much straighter, shut up. 255, 375, and I'll call this F for force. And that's going to be theta later on. So a half mark for the drawing. You could also go 375 up and 255 to the right, tip to tail. That will also get you there. The magnitude. Pythagoras is going to be 255 squared plus 375 squared equals 453.5. I'm going to go technically to 3 sig figs because the data they gave me is to 3 sig figs. So I'm going to go 453 newtons at opposite adjacent tan theta equals 375 over 255. 375 over 255. 56 degrees north of east. Or I would also take 34 degrees east of north. Half mark, half mark, half mark, half mark. Turn the page. All right, some application questions. Motorboat heads due west, river flows due north. So I guess this time, Connor, we're going to draw the river flowing north. And yep.
I think the last one is north.
Last one is what?
North of east of the
56 degrees north of east or 34 degrees east of north?
I didn't see the
Okay. Thought I made a mistake, please. Actually, you know what? It's since we're almost done a whole year with me, it's completely understandable if you thought I made a mistake because I'm sure I'm into almost triple digits this year.
I saw the big glance.
Yeah, you just wanted to show that you're smarter than me. Bring it on. Justin never would have made that mistake. Anyway, okay. Wait, hey, which way is the boat moving, Michael? Oh, hang on. Before I do that, Michael, I've turned the page. By the way, another thing that you might get in the habit of, and I do this with my grade 10s when I teach them trig, anytime I turn the page, is they also, at the top of the page, they write that, because in trig and math 10, you're doing trig on every question. Certainly, that might be a good habit to get into, or when you get your test, it might be worth writing it at the top of your page on the test, right? Little tricks of the trade. Boats moving which way, Connor? I was picking on you, I think, actually. Read the question. Which way is the boat heading?
West.
How fast?
8.7
So boat's pointing this way. 8.7. That's an 8. What's the river's speed?
Wait, it says due west.
Oh, you see? I do this all the time, even with the compass rose. Thank you, Connor. Michael, you're feeling vindicated. I did make a mistake. You were just anticipating my mistake. Your timing was off. You knew it was coming. 8.7, thank you, Connor. And which way is it flowing? North, how fast?
3.2.
So the boat is pointing straight, but the river is pushing it up, so I can see it's going to be traveling kind of that way. Oh, that sounds like a resultant. I'll add these tip to tail. I'll go 8.7 plus 3.2. And again, you'll notice, Jordan, I tried to be roughly to scale. 8 is close to 9. 3, I tried to make the 3. You know what? Really, I should even probably do this, because that 3.2 should be about a third as long, give or take. And the resultant is going to be, yoink. And, it's a velocity, so how about I use the letter V? If you really want to, you can use a V with a subscript R for resultant velocity. It's up to you. Again, this is a nice right angle, so I can do some trig here. The velocity is going to be Pythagoras 3.2 squared plus 8.7 squared. Hopefully you're finding Pythagoras, compared to Math 8, a walk in the park now, where you're almost going all calculated. If you are, great. If you want to show more work, Nate, that's also fine too. Don't forget the square root, Mr. Dueck. Do you get 9.3? 9.27, but I'll go to 2 sig figs because this is to 2 sig figs. 9.3 meters per second at yoink. Tan theta equals opposite adjacent 3.2 over 8.7. 3.2 over 8.7. 20 degrees. What of what? North of west. Or, Michael, my friend, 70 degrees west of north if you drew the 3.2 first and then you went 8.7 to the left. Same old deal. Half mark, half mark, half mark, half mark. So far, so good. Now, let's do some applications. By the way, I like this question. I like this question. I like this question. I like this question. B, if the river is that wide, you know what? Let's draw that in. It's saying, what if this distance here is 83 meters? McKenna, notice how I drew that distance. It's a horizontal distance in my picture. You know which velocity I'm going to use? The horizontal velocity. Not the slanty 9.3, not the 3.2 pointing up. I'm going to use the 8.7. And I'm going to say, well, D equals VIT plus 1/2 AT squared, except A is 0. I'm really going to say this. Horizontal distance equals horizontal speed times T. Is that okay, Callum, so far? What are they asking me to find, Callum? How would I get the T by itself? D, 83 divided by V, 9.3, no, 3.2, no, 8.7. I want to have everything line up in the same direction. Now, I think when we did the river question, Zach, what I did differently was I gave you the resultant. I gave you, and if you look at your notes back, that I did the slanty velocity. I gave you that, and we broke it up into components to find which way the boat was, how fast the boat was going, and the speed of the current. I have no problem doing either giving you both components and saying find the resultant, like in this question, or flipping it around. 9.54 seconds. How far downstream? Okay, now they're asking me to find, well, except the boat's going to be flowing upstream, Mr. Dueck. Shut up. Okay. They want me to find that distance. The boat's going to be moving upstream, and I guess I should really call it upstream since it's up the page, but whatever. They want a distance. It's a vertical distance. That's going to be a vertical velocity times time. Again, Matt, plus 1/2 AT squared, but A is 0. It's going to be, what's the vertical component? 3.2. What's the time? 9.54. 30.5 sounds good. Technically, if I go to 2 sig figs, 31 seconds, but whatever. Turn the page. Oh,
Yeah.
that's a distance? Sure it is. Meters. Thank you. Welcome back. See what happens when people come late? It throws me off my whole game. Heavy box is pulled to the right across the wooden floor with a rope. The rope makes an angle of 50 degrees with the floor. Oh. Dope. I'm going to draw a picture. So here's the floor. Here's the rope. It says that we're exerting a force of 123 newtons, and it makes a 50-degree angle. Well, we're going to break this up into horizontal and vertical components. And part A says it wants me to find the horizontal component. Well, that's hypotenuse. That's adjacent. I think it's going to be cosine of 50. I think it's going to be fx equals 123 cosine of 50. I think it's going to be 79.1 if you want to put that in there as well. Newtons. Find the vertical component. Well, the vertical component is going to be almost identical, but it's going to be sine. It's opposite over hypotenuse, which is fx over 123. It's going to be, is that not fx? How about call it fy, Mr. Dueck? Fy equals 123 sine 50. Sine 50, 94.2 newtons. By the way, the other way you could find Fy, you could use Pythagoras. You could go 123 squared. Oh, got another latecomer. You could also go 123 squared minus 79.1 squared square root, and it should be close to 94.2. There's a way to check your answer, Jordan. If you can get it with Pythagoras and with SOHCAHTOA, you're probably right if you got the same answer both ways, all likelihood. Number 5, two forces act on an object. One force is 8.5 newtons due west. The second force is 12 newtons due north. Find the resultant. I need to draw a compass. West. Yoink. Got it right that time, Connor. Shut up. North. Yoink. Tip to tail. West plus north. Oh, it's a force. I'll call it F. So my resultant force F is going to be 12 squared plus 8.5 squared. Square root 14.7 newtons at yoink. There's theta, opposite over adjacent. I have tan mystery angle theta equals opposite over adjacent. Inverse tan of opposite over adjacent. You get 55 degrees, 54.7. I'll go 55 degrees. What of what? North of west, or this is a 35 degrees west of north. Same old half mark for the diagram, half mark for the magnitude, half mark for the angle, and half mark for the what of what. B. B is going to be a bonus question, but it's a nice concept. B says find the what? What is the equilibrant force? The equilibrant force, AJ, is the force that exactly cancels out the other two forces. Okay? And by cancels out, I mean that so that when you add it together with the resultant, you get 0. It's going to be a bonus question, but the equilibrant force is going to be 14.7 newtons at, the angle is going to be 55 degrees, but you want to know the force that exactly cancels out. It's going to have the same magnitude, but instead of north of west, you know what it's going to be? South of east. So if you got that, 2 free bonus marks. I can't remember if I gave that term to you in the notes or not. I don't think I did, and I think I keep meaning to add that to my notes every year, and I keep forgetting. Why would you need to know that? Well, in Physics 12, we do a whole unit on equilibrium, and specifically one of the things we'll be asking is, well, if you know something's not accelerating, if it's hanging in midair, then you know all the forces are balanced. If you know 2 forces, you can figure out the third one to keep it in balance. The equilibrant. Airplanes. A couple more. A pilot wants to fly, oh, this is tough. A pilot wants to fly directly south. Oh, and I like number 6. I think I like number 6. A pilot wants to fly directly south. The wind is blowing 125 kilometers per hour towards the west. So from the east towards the west. I'll make sure I draw that one right. Plane is moving with an airspeed of 445 kilometers per hour. At what angle does the pilot have to aim the plane to actually travel directly south? Which way is the wind blowing? West. Yoink. The pilot wants to, don't write this down, end up flying that way. If the wind is pushing him to the left, which way is he going to have to point his airplane slightly? You know what? They didn't give me a direction, but I can tell you that I'm pretty sure his airspeed looks something like that. Oh, and I know the magnitude. How fast does it say he's got his engine pushing at? 445. Okay. How do I add 2 vectors together, Jordan? Draw them. Now, here's where I can be clever. I draw the 125 first, and then I go start drawing the 445. But here's the nice thing. I know what the resultant is supposed to look like. When I add these 2 together, which direction does the question say that I want to end up in? Hakeem? Due south, which means don't draw it that far, because when you draw it, that's not going to give you due south. And it means don't draw it this far, because when you add those together, that's not going to give you due south. Tell me when to stop. Right there. I can figure that out by being clever. Stop right there. That's 445. And here is my resultant. Not a hypotenuse, which is kind of a nice change. Also, kind of a useful question. Again, Matt, it's all done with GPS and computers now, so okay, humor me. But 50 years ago, certainly, this is some of the math you were doing in the cockpit. Because you want to fly short, straight line there, less fuel, less time, quicker way to get there. Here it's going to be Pythagoras, but I'm going to end up subtracting, because it's not a hypotenuse. So the resultant is going to end up being 445 squared minus 125 squared square root. 427.1, I'll go 427 kilometers per hour. Oh, sorry, that's the answer to B, right? The speed. You could add a direction, south, except they said speed, which is a scalar, so I don't care about the direction. That's your answer to part B. Part A, they want at what angle. You know what? I think they're talking about that angle there, which is going to be adjacent hypotenuse. Not tangent for a change. Riley, which trig function am I going to go with here? Adjacent and hypotenuse. Cos. Cos of mystery angle equals adjacent over hypotenuse. He wants to point himself 73.7 or 74 degrees. 74 degrees what of what? South of east. If he points the plane that way, if he puts the plane on a compass heading like that, he'll move the plane due south. 2 marks. I guess I'd probably go something like this.
He's on the opposite angle, 16 degrees.
Oh, I would also take 16, come on, pen, degrees east of south. By the way, it's not the opposite angle. It's called the complement, for what it's worth, says the math nerd. But okay, what if we got the complementary angle? Yeah, I'd take that too. And you know what? I would probably go something like this. 1 mark for the angle, a half mark for the what of what, and a half mark for the vector diagram. Here, well, I guess just plain old 2 marks. I should have made that worth 1. I don't know. So I said that the 5B was bonus. So that means I think this quiz is actually not out of 19. I think it's out of 17. Let me double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Nope, don't count that. 14, 15, 16, 17. Sure, give yourself a score out of, count them, 17 at the top of the page, please. Questions from the homework. Number 10. Ooh. Hey, yeah, this is very similar to the last question on the quiz. I'm trying to remember if you're going to see this Thursday or not. This is a tough question. I think I have a couple of different versions of tests. I know it's on one of them. I came in here on Saturday and I photocopied your test, and the photocopier jammed a dozen times in 2 hours, and it jammed royally in about 8 different places. I reached the point where I could do it in my sleep because I kept on unjamming it, but the result was I was so frustrated and angry, I really don't remember which version of the test that I photocopied. I was just sitting there going, it's the last sunny day, it's going to rain tomorrow, and I'm stuck here with a stupid wrist. Anyways, so point being, you may, when I said I like this question, I know I have liked this question in the past. Pilot wants to fly what? You know what? I better draw a compass. How about right here in the margin? North, east, south, west. We want the resultant to be west. The plane has an airspeed of 95 and there's a wind blowing north. What direction? So here's what we're saying, I think. The wind is blowing to the north. I'm not quite sure how I'll draw his airspeed, but I want it to be exactly that way. Well, I think what that means is if the wind is pushing me upwards, I think I'm going to have to aim which way so that to cancel it out. If the wind is pushing me north or upwards, which way am I going to have to aim? If the wind is pushing me upwards, which way am I going to have to aim? Downwards. Yeah, thank you. Yeah, I know it's the opposite way. Thank you, Captain Obvious. I was looking for more specific than that. So, you know what? I think it's going to look like this, Michael. I think it's going to be... Let's try that again with the pen working. Come on, pen. Got a dead spot on my screen somewhere there. It's going to look like this. North 25... And remember, I want the resultant to be west, so I'm going to point the airplane, and I know to stop right there. I'm going to point the airplane like that. Now, my scale is terrible, but that would give me a resultant due west. So if they want the direction, it's going to be... Oh, I drew the arrow wrong, Mr. Dueck. If they want the direction, it's going to be this theta right here, which is going to be west of south. Yeah? West of south, angle, hypotenuse, adjacent. Oh, this one's going to be cosine again. It's usually tangent, not always.
Why wouldn't it be west of north?
Why wouldn't it be west of
The
north?
first arrow is pointing north.
The first arrow is pointing north, but look at how I would draw this. To draw this, I would go, is it going to be west of north, Mr. Dueck, or am I west of south? I am, go north, then go, it's west of south.
That's what was confusing me, though, because the arrows are pointing.
The way the arrows are pointing. The reason is, this is my resultant here, so I can't use my usual trick. What I really got to visualize is to get to that way there. To get to that way there, I would start out heading south, down, because it is pointing down, and then I would go to the left, to the west of the original south. I'm not actually looking at this arrow for my resultant. I'm just treating it like a big straight line and saying, what's this line doing? It is pointing west and south, south and west. So it's either south of west or west of south. Which one? And then I look at where my theta is. Is that okay? I don't know if that's a great explanation or not. I hope it was cleared it up. Anyways, it's going to be cos theta equals 25 over 95, and I'm guessing you'll get 15 degrees, I hope. Oh, 75 degrees. I got the bigger angle. 75 or 4? 75 degrees west of south, or 15 degrees south of west. The 15 degrees south of west would be if you drew the airplane's 95 and then drew the wind. For these complicated ones, we do these in grade 12, physics 12 more, and Michael, what I teach my students is always draw the easiest vector first, the one that is either up, down, or left, right. Draw that one first, because that gives you kind of a reference point to draw the complicated one and know when to stop. Is that okay? Any others? Going once. Okay. What else is due Thursday? Well, this sheet here called vectors, except I now have included the ones that I didn't before. So you can add number 5, number 6, number 7, number 8, number 9, number 10, number 11, 12, 13, 14, 15, number 16. In fact, basically, you can nuke 18, 19, and 20, but the rest of those are also fair game. Okay? So, on Thursday, because that's actually your review assignment. I gave it to you early in chunks, but the unit review has always been this big vectors one here. I don't have a separate vectors review assignment. So on Thursday, you're going to hand in this one. It's not going to be out of 49, but probably worth 20 marks because it's a unit review. And velocity vectors and navigation. If you haven't handed in practice exercises, vector additions, you can hand that one in as well. There is about a half an hour left in class. I was going to start another lesson. I'm not going to. We did start the next unit, so let me just make sure. We started projectiles. We did do lesson 1 on free fall. Was there anybody who didn't get the notes on free fall? I think a couple of you were away. Lesson 1 of projectiles. The homework I assigned was skip 4, skip 9, skip 11. So for Andrew and Zach and Elijah and Jordan, skip 4, skip 9, skip 11. Most of this was, in theory, good review, and I liked it because we are towards the end of the year. Really what we were reviewing was free fall and D equals VIT plus a half AT squared, VF equals VI plus AT, and VF squared equals VI squared plus 2AD. And then there's the fourth one that has the 1/2, the VF, the VI, and the T that I never even memorized because we hardly ever use it, but it's there too. Okay? So you can also work on that. I'm gonna shut up.